Welcome everybody to today's lesson where we will be talking about sorting data. Now we're going to be covering two algorithms. The first one is going to be called bubble sort and the other one is going to be merge sort. Now before we get into the actual algorithms themselves, we're going to talk about what sorting actually is in general. So before we begin on the algorithms, as I said, what I want you to do is think about these three questions here. And the first one asks you to look at figure 1 on the right hand side, where you have an array or a list or a set of numbers, not in any particular order, they're random. And what I want you to do is think as a human being, if these numbers were in front of you on pieces of paper, how would you go about sorting them and putting them in the correct order so that they are in ascending order? So if you want to pause the video, it's entirely up to you. Just think about what are the steps that you would have to take as a human being, not as a computer, to put these numbers in ascending order. The second question asks you whether it's possible to do the same thing, not with numbers, but with characters. Now this activity isn't to waste your time, it's to get you to start thinking critically, it's to develop your mind. So if you really want to do it, it's for your benefit. Think about whether the same steps that you've used to organize this data into an ascending order, could you do the same thing with letters, with characters? Now, if you can do that with characters, and you've done it with numbers as well, what I also want you to think about with this third question is how would you need to change the process that you use to put these numbers in ascending order? What would you have to change to actually sort them in descending order, right? So if you want to pause the video, as I said, think about those questions for a second, or you can think about those questions as we go through the lecture. It's entirely up to you. So let's move on to the first slide. Now, this is going to put us directly into an activity. So this activity is very basic, and don't worry about the fact that it says on your learning mats, because I use this presentation in my lessons, so you're not going to have this mat at home. You can just use a piece of paper if you wish. That's up to you. So the activity is very simple. You look at these four lists, and what you need to do is you need to organize the data that's on the unsorted side into an ascending sorted list on the right hand side of each table. So if you want to attempt this activity, please pause now and we will check the answers once you unpause. So welcome back if you did pause the video. Let's have a look at these tables and how we would sort them out in ascending order. Now the easy one is, well, quite easy. We know that the smallest value from these numbers is -6. Then the next number is going to be 24. Then we have 27. Then after that we have 56. Then we have 57 and 102. So success. If those are the numbers, or if you put those numbers in that order, give yourself a green tick because you got them correct. Now we can see here that we're using the value of the numbers to decide where the number goes in the order. Now looking at the second table, you might be a little bit confused because you might be thinking that these these strings, these words here, don't actually have a numerical value, but in fact they do. Remember, in computing, every piece of data has a numerical value, and we're going to have a look at that in a second. So what your computer does is it looks at the word here and it focuses on the first character of the word. Now, if you are not familiar with the ASCII table, I'm going to put it on the screen now, we can see that the lowercase a, I'm just going to move it a little bit to the right here so we can see those words. We can see that the lowercase a has a numerical value, which is 97. Now, every letter that comes after this, this letter has also a numerical value, which increases by 1 with every letter of the alphabet. So a, the lowercase a, has the smallest value amongst these words here, because they're all lowercase. So what you would have to do is you would have to, I'm just going to remove this, this ASCII table here. So what you would have to do is you would have to put the word algorithm as the first item on your list. The next word that's going to go here is going to be bubble. B is the second letter of the alphabet. So if A is 97, B is going to have the value 98. So we would have bubble like so. The next word is going to be data type. After data type, you would have efficient. And now we have two words with the same starting letter, swap and sorting. This is where the computer would then look at the second letter and decide based on that where it goes on the list. So sorting would go first and swap would go second. So here is a sorted list in ascending order of the words on the left hand side. Now let's have a look at the hard one. Looking at the data here on the unsorted side, what we would have to do here is we would have to look at all of these words, and again, because they have quotation marks, they're not actually number values or integers like the first table. These are actually string or decimals from the ASCII table. Now, even if they are just decimal characters, 1 would still be of a lower value than 5, because again, if we have a look at our ASCII table here, we can see that the character 1, or forgive me, the decimal character 1 is the value 49 in the ASCII table. And again, just like the alphabet, every number or every decimal character after 1 has a value which increases by 1 as the numbers go up. So let's remove our ASCII table so we can have a look at this. So don't worry about these little lines that I've put. So the number 1 would go first. Now your instinct would tell you to put the number 3 second, like this, but in fact that would be wrong, because these are characters and they're being treated as string because of these quotation marks. Remember, just like in the OK table, we're only looking at the first character here. So the second item in our array here will actually be 10. And then after that we would have 1075. But remember, this isn't a number value, this is text. So after this you would have the number 29. Then after this you would have 3. And then after this you would have the decimal character 5. This will be the correct way of sorting the data out, because we're only looking at the first value in every piece of text. And if this, if the first character is the same, like we see here in the first 3 items, then you would look at the second values after that. And of course, if it doesn't have any values, then it's of a higher value than the other ones. Now let's have a look at the brutal one here. So again, what you would have to look at here is the first character of every piece of text, because it has the quotation marks. Now if we again look at the ASCII table, we can see that the minus here, the subtract sign, has the lowest value of all of the characters that are in there. So what we can do here is we can look at this value here, -7, that one goes first. Then the character 1 here, 17. Then we would have the character 7. Now looking at just these three here, we know that the capital letters in the ASCII table have lower values than lowercase letters. I know it's a bit weird and it's a bit tricky to get your mind around this, but uppercase letters have lower values than lowercase letters. And again, if I bring up that ASCII table, we can see that the capital letter A has a value of 65 and the lowercase a has the value of 97. So from these two numbers, from these two words, we would have 7, and then we would have 70, and then we would have 7 with a lowercase s. So this would be the correct way of ordering these this data in ascending order. Now the next slide is kind of going to just give us a bit of an introduction into what sorting actually is. So sorting data out, it's a fundamental process of arranging data in a sequential order. So this is either ascending or descending. Ascending meaning the lowest value first, descending meaning the highest value first. Now, to achieve this, to achieve an ordered list, all of the items that you are sorting out, so this refers to sorting out things in computer science, not in the real world, each value or each item in the array has to have a numerical code. So this is where your encoding tables come in. So this could be your ASCII or it could be your Unicode. Now, what the encoding table will have, again, is it will have a character that's been assigned a numerical value. Now, that numerical value is what's going to be checked, and for an ascending list, we need basically the value of the first item in the array to be either less than or equals to the value of the second item in the array. So, for example, if we have the capital letter A in the first item, and then we have another capital letter A, and then we have the capital letter B, this is an ascended array because A, which is represented by 65, and A by 65, and B by 66, we can see that 65 is less than or equals to 65, and 65 is less than or equals to 66. So this is a correct way of ordering a list in ascending order. And then this kind of goes on until, well, however long your array is. If one of these items, or if one of the numerical values for these items doesn't match this formula of less than or equals to the next item on the right hand side, then you do not have an ascending ordered list. So for example, if you have again A, comma B, comma A, so we have 65, 66, 65, we can see that the second number here is not less than, neither it is equal to the next item on the list. So this would not be an ascending list. Okay, now looking at descending, you just basically flip it around and you have here a numerical value, which is your item 1, which is greater or equals to the next value here in the list. So if that, for example, is BA, like so, and again A, we can see that 66 is greater or equals than 65, and 65 is greater or equals to 65, and so this is a correct way of doing a descended list. Okay, now this bit is very important for you to understand, that the reason why we sort the data in computer science is so that when we search for that data in those lists or in those data structures, we can find it much more easier using some very, very intelligent algorithms out there that are used for searching for data. So the reason why we sort the data out in a data structure, such as in an array or in a struct or in an object or class, is basically so that we can search for that data with ease after we have sorted it in either ascending or descending. For example, if you had 20 straws and they were all of different lengths, and you wanted to find the medium size straw, then if you put them from shortest straw to the longest straw, then you would just automatically know that the middle one, or the mid-height one, would be in the middle of your sorted straws, because that's the first place you would look. So instead of measuring every single straw against each other to find which one is the middle one, you just put them in an order and you just pick the middle one, because that would be the one that you would want. So again, sorting data is done so that we can search it with ease. Now, without even getting into computer science and why we sort data out in computer science, sorting is something that human beings have done for centuries here in this world. And if we just look at one of those examples from history, we can look at how the Egyptians used to order their or sort the names of their kings on a wall. So we have this with this list of kings here. This is from the Abydos temple, and you can do some research on this if you wish. But what they used to do is, instead of ordering or sorting the names of their kings based on the time that they ruled, what they used to do is they used to sort the names of their kings based on an alphabetical value. So I'm not really familiar with the alphabet of that time, but the kings with the letter A would go first, and the kings with the letter B would go second, and so on and so forth. And it's quite amazing that humans thought of these ways to order their data. It's quite amazing. Now, in computer science, we would use these algorithms to either sort the racing times for Olympic athletes. So if you had 10 athletes doing a 100-meter race, and you have 10 different times of the race, then what you could do is you could sort those race times out, and then the first item in there would just be the fastest, and you would immediately know who the winner is. You could also sort out your, if you were a teacher, you could sort out the grades of your students in descending order, and then the ones at the beginning of the array or the data structure would tell you which students got the highest grade. You could sort words in a dictionary, and so on and so forth. Have a think about what other places in computer science, or what kind of situations you would need to sort data out to be able to make your life much more easier when you have to search that data for something. All right, now this brings this part to an end. In the next video, we're going to start talking about the algorithms which go sort of hand in hand with the bubble sort.